Good morning, everyone. My name is Admin User with Slack Gizmo Tutorials, here to bring you the second in our series of Getting Started videos. For today's video, we will be going over a variety of different use cases for the OpenFIDO application and taking you on a test run of essentially a number of different validation pipelines and resources. And so this will essentially show you how to utilize the platform a little more in depth and some of the different examples of things that you can get out of it. So with that out of the way, let's dive right in. The first thing we're going to need to do is we're going to need to add each of our requisite pipelines. So for my validation run here, I'm going to be utilizing a SIME pipeline, load shapes, weather data, polls, and a resilience analysis. With that stated and gotten out of the way, let's get started. The first thing we're going to need to do is add our pipeline. So depending on your organization, you might have a certain number of pipelines already available. For this demo, I created a new organization that's currently empty, so we're going to be building each of our pipelines as we go along. Now, as I've demonstrated before, all of our currently available public pipelines are available from our OpenFIDO organization on GitHub, and we're currently able to get access to any one of them here. So since the first operation we're going to be running is a SIME analysis, we'll be pulling from SIME extract. And so what that will enable us to do is that this will pre-fill all of our information for the SIME extract pipeline, so we can now promptly add the pipeline and work with it. Now that our pipeline's been added, we can be able to go into it and start our run. Now, some things to keep in mind is that while you are doing these runs, you want to make sure that you have your settings updated for any of your online applications, so that way you've got plenty of data space, because each of these runs will be running into a Docker container, and so that is going to be an organization-specific setup. So for our website, we can generally run about 2 Docker containers simultaneously before they start running into a little bit of space issues. But otherwise, if you have your EC2 settings set up right and plenty of storage space, you can scale up the number of different Docker containers for simultaneous runs essentially as much as you need. So on a system that's native or on a virtual machine like this, being able to scale is a pretty much very simple and easy process. I can go into more detail for that for the developer videos, but that's just a quick heads up on the pipeline runs. So now that we've got our SIME extract pipeline added, the next thing we're going to want to do is start our run. So when this pops up, we get some options. We've got our manually fillable configuration form, as well as a drag and drop for our files. So for this one, we're going to want to open up our manually filling the configuration form. Next, we're going to want to add in our SIME database. So this isn't going to be just any MDB file. We want the IEEE 123.mdb file. And this is a file that I can either fill manually here. I can select my upload button to select the file that I need, which will be located through this directory tree into our tutorial files here. Now, if you grab a file from here to upload directly, it'll also have a fun little effect of pre-populating the name based off of the file. Let's actually show with our drag and drop. And now we get the IEEE 123 form. And as you can see, it's also been set up for upload. The next thing we're going to want to do is update our nominal voltage to 2400 volts. Then next, our GLM files to include would be config.glm. So here, let's go through our directory tree and do a fun little upload. So that will add our config.glm. And any of these you can drag and drop. Just keep in mind that any drag and dropped files you're going to also have to manually name in your config.csv. The next thing, our model fix, is our modify.csv file. Then we want to add our settings.csv. So that would be an upload file, just settings.csv. That we don't have listed as our config, but it's something that we need. So we will add it with a classic drag and drop. We will add it with a classic drag and drop. I see. There we go. So there was a little bit of overlap here between my my finder and the actual drop zone, and that was making it particular. So once this highlights blue, you know that the file is now over here and ready to be dropped in for the classic drag and drop style. And now that all of that has been uploaded, all of the rest of this does not need to be changed. So at this point we can submit our form, which now will also upload our config.csv. Now once we start our run, you'll be able to see the run status as it begins and goes. Here we get our console output, so we can see in our standard output it's doing a Docker pull for GridLabD, and our standard error, nothing yet. And so these update as the run progresses. Boom! So now that our run has finished, we can see our output artifacts list along with our console outputs have fully updated. So pulling all of GridLabD was quite an extensive process, and it seems that once that was done, everything else ran pretty quickly. And so you can then go through essentially the console output and see everything that your run was doing along the way. So that helps particularly in the realm of bug testing. Anything that might be an interesting or strange result, you can then run and compare and see the different commands that have happened, and it'll help you really dig into and identify your analyses and hopefully be able to improve it or do whatever it is you need to do. So now that we've got all of our artifacts out here printed, we're going to then want to download a few different files. So now that we have our run completed, you can see that we've also gotten a number of our different artifacts available for download. So the next run that we will be testing for demonstration purposes is going to be our generation of loads from AMI. That's going to be utilizing load shape. So for that, we're going to navigate back to our pipelines and select add pipeline. Now this one we're going to need to go and add our load shape analysis pipeline. This pipeline, once we have our run set up, we're going to want to upload just a couple of different items here. And so this one, we're going to want our AMI data file located up one AMI data.csv.gz. Then we're going to want to also set our load mapping. Our load map will go into let's see here, our CSV upload, output load load shape.csv, load map input CSV under our gridlabd section. There we go. So let us put our load map into there. We've also got some options for verbose and debug input, which can be handy, but we don't need to make use of those. So now we can just submit this form, and we can start our load shape analysis run. Now it is updating our console output. As you can see, pulling a Debian 11 is a lot faster than pulling something hefty like gridlabd. Very useful, gridlabd, but we'll be doing some work to make it a lot faster for install and download. And now the load shape run has completed. We've gotten all of our different GLM, CSV, and PNG images and files. So next, we can run through getting our weather data. For our weather data, we're going to want to go back to pipelines. We need to add in a new pipeline for weather. Add that pipeline, and again, we can go through and start our run. And this one is another one that uses a simple standardized configuration file. And so for here, we're going to manually fill out our config form. Our presets here are actually precisely what I would want. And so I can just simply submit and start a run. And you can change those detail presets to whichever you find most useful. Alright, so now that we've got our weather pipeline up and running, for the Astute Observer, you may note that I have changed over to app staging. I could also utilize our production application to do weather runs as well. But I'll be using our staging application for the duration of this this demonstration of use cases. Reason being is that my local system was having some space issues, and so I decided that I'll also just show the demonstration working off of our online resources. So now that we've got our completed weather run with our artifacts, we shall build our data visualization chart off of our forecast.csv file here. We're going to utilize a line style of a chart with our x-axis taking our date time values and our y-axis taking our temperature values. And our chart we shall simply call forecast because I am an infinitely creative individual. And so now you can get to view and run along our chart, seeing how the temperatures are changing over time. So now that we have worked through our weather chart, we can also download our artifacts for later use, our forecast.csv and our forecast.glm. You can simply just save the file. And if I wanted to open it, boom, we get our list of date, time, temperature, and other data. So next, we will be running our polls test. So as you can see, I've got a long history of different things, whether we were running grip, feature testing, that kind of fun thing. So now we're going to demonstrate our polls, and this is going to be based off of our poll create pipeline. So once we have now added poll create, we can go through view and start the run here. And so this one is going to be utilizing a few files from that task. Let's see, we already did weather, task 4, add polls to model. And so this one, we're going to want to take our IEEE form and upload that to our input model here. And then we're going to want to upload our poll data CSV over here. Our output, we want an IEEE 123 polls.glm. So let's update our name here. We want the IEEE 123 polls.glm. And that's just giving our file our naming convention, so that way we know precisely what we're getting and why. And so now we can submit our config form and start our run. Our output here is updating. The nice thing is that once the image has been pulled on OpenFIDO, the first pull for the image for the container it's running within, that generally might take some time. But now, thanks to the image having had it cached, it can actually jump into the analysis much quicker. And as you can see, this will have a much faster run than some of the other pipelines that I've had to edit over due to the amount of time it took for it to pull the image and build from scratch. So now that we've got our IEEE 123 poll.glm, if we wanted to, we can download this file for later use. So I figure may as well just, let's take a save on that. And now that we've got that file, if we wanted to go look at it, we can just open it with any old text editor as the GLM file, and you can see everything that we have gotten in terms of the polls. And so that is poll creation. Next is going to be our final task, which is going to be running our resilience analysis. And so resilience is quite important for a grid-based system because you don't want anything going down. So this will help us find our different weak points potentially in a system. So we want to select our poll resilience pipeline and add it just like we have for all of the other ones. And any of these names, when we add them, you can change it at adding time. As long as the core data is all there, we're fine. So you could just change up the name. That will have no effect on the pipeline. The important parts are here for our Docker Hub repository and our cloning URL, as well as the branch and the entry point script. These guys are the core, and this is essentially your flavor. So let's go back to our pipeline for poll resilience. And we are going to be running our resilience analysis. So we're going to again start a new run and fill out our configuration form. Now this one, you may notice, will take a lot more files. And so that is always a fun time. And so essentially you would have downloaded all of these different files over the course of the analysis. And these files I've got handily pre-set up for you, so that way we can have a nice and speedy demonstration. So we're going to want our IEEE 123.glm file. That goes into our network here. For our configure field, we're going to want our config.glm. For our polls, we're going to want polls.glm. I see I should have kept that initial naming scheme there, but the IEEE poll file is essentially the one that we've been downloading and using. So stick with the same name scheme. Recorders, we are going to want recorders.glm. We're going to want our weather model data from our forecast.glm. We're going to want our forecast CSV as well. And last but not least, our settings CSV. Our time step is fine, and so with this, we can submit the form and start our run. As we can see, it has updated here to our poll resilience test. And now we give it a minute to do and finish its run. Boom. Now that the run is done, we can download our CSV here and take a look at the results. I always like to save our files. And so now we can see, based off of these results, our list of polls here, and we can find which ones have failed based off of our resilience analysis that took in our different weather data and other elements. If I recall correctly, this is simulating essentially a high wind event, and it's finding out what polls based off of tilt and other things would be able to survive. And so yeah, that is our general demonstration here for our use cases for OpenFIDO. My follow-on videos, as I mentioned in getting started, will be targeted specifically for our pipeline users and for our pipeline developers, and those will be in their own respective channels. And so those are going to go more in depth into, as a user, building and using your own pipelines, and for developers, that's going to be for working on the OpenFIDO application yourself, either as a contributor or a prospective contributor. So thank you very much for your time, and as always for this video, have a very happy holiday season.